Hello and welcome back to another episode of Math with Miss Murthy. Today's lesson is lesson 8.4, area of regular polygons, and this begins on page 463 of your textbook. As usual, pause into the warm-up on your own and I'll share the solutions, and also pause for reading the standards for mathematical content and practices. Great. Today's lesson goal is to find the area of regular polygons by decomposing the figure into other figures. Now we've kind of done this before. So first off, before we start, what is a regular polygon? A regular polygon is a polygon which has all sides equal length sides and angles. Okay. So to find the area of a regular polygon in which all sides and all angles are congruent, we can decompose the figure into triangles, parallelograms, or trapezoids, and then we find the area of each smaller figure, and then we add or multiply as needed to find the total area. Okay, now let's look at this hexagon, for example. We're going to decompose the figure into two congruent trapezoids. What does congruent means? They are identical in size and shape. Okay. Now we know that this side is 2 centimeter in length. This is 4 centimeter, and the height we're given here is 1.73 centimeter. So how do we find out the area of a trapezoid? Right? Let's see. So what is it that we know about finding the area of a trapezoid? It is half h times b1 plus b2, and b1 and b2 are the two bases. So our first base is b1, that's 2 centimeter, and our second base is b2, which is 4 centimeter. And our height is 1.73 centimeter. So when you substitute that, you can figure out that A is 5.19 centimeter square. Don't forget the centimeter square. Now that's just the area of one trapezoid, and we're going to double it because we have two such trapezoids. So our total area is 10.38 centimeter square. I want you to take a moment and think about this. Is there another way that you can decompose this trapezoid? Is there another way? Well, you could think about it as, let's say you decompose it into a rectangle and you have two congruent triangles over here. And then, so those would be your section 1, 2, and then this rectangle. And how do you know what the height and the base of the triangles are? Well, for the rectangle, you can say that the rectangle is going to be 2 times, you know that this height is 1.73, so 1.73 times 2, that would be that side, so that would be the area of the rectangle. For area of the triangle, I could say, I'm just doing this really quick and do it here, that would be half times the height. Now the height, we know that this width is 2 centimeter. That means this balanced width is going to be a total of 2 centimeters. Since they are congruent, they would be, each of those would be 1 centimeter. Half times height times the base is 1.73 times 2. And if you solve this, you will see that it works out to the same total area if you add them up. Now let's take a look at example 1. This is on page 464 of your textbook. A stop sign is shaped like a regular octagon. Each side of the sign is 15 inches long. As you can see from here, each side is 15 inches long and measures 36 inches between parallel sides. So if these are your parallel sides, the total distance is 36 inches long, right? So now we have to find the area of the octagon. How are we going to do this? Now, we know that an octagon has 8 sides. Well, first off, before we go there, I want to think about this first. Is the area less than, greater than, or equal to 36 square, which is 1296 square inches? And how do you know? Well, what is the 36 they're talking about? The thing that we know is this height distance between the two parallel sides is 36 inches. If I were to, let's say I were to draw a square, right? Now I know that this dimension of the square is 36 inches, as would be this dimension. So the area of this square is going to be 36 square. How about the octagon that fits inside this? As you can see, there are these spaces that are not a part of the octagon. So the area of your octagon is going to be less than 36 square, which is 1296 square inches. Now let's decompose the octagon into congruent triangles. How many congruent triangles are there going to be? We know that the octagon has 8 sides, so it's going to decompose into 8 congruent triangles. Now what is the base of each triangle? We know that the base of each triangle is 15 inches. What do we know about the height? Because what do we need for the area of the triangle? Half base times height, right? So we know that this base is 15 inches. And the height, as we saw before, it's half the distance between the parallel sides. So my distance between the parallel sides is 36 inches. So my height is going to be 18 inches. So area of each triangle is half times 15 times 18, which is 135 square inches. And we have 8 such triangles. So our total area is 8 times 135, which gives us 1080 square inches. Now, before we move on, time for trivia for the day. Can you tell me what is on the top floor of the US Supreme Court building? On the top floor of the US Supreme Court building is the Supreme Court gym, which also has a basketball court, which is named the highest court in the land. All right, moving on. With this given information, can you decompose the octagon into different shapes to find the area? Why or why not? Think about this. We'll talk about this in class. All right, moving on. I want you to pause and do this check problem on your own. And here's the solution. All right, looking at our apply problem. Kaylani designed a gazebo and wants to cover the floor with tiles. The gazebo is shaped like a decagon with 3.75 foot sides. If floor tiles cost 2.89 per square foot, what is the least amount she will spend on tiles? Now the least amount assumes that with just the minimum amount of tiles you're able to completely fit in. You don't need extras to cut and make those smaller pieces. That whatever you have with the minimum, you'll be able to make all the different size smaller pieces that you will need to cover this, right? So what is it that we need to find? How many sides does the decagon have? The name decagon tells you that it has 10 sides, which means we have 10 triangles, right? So what else do we know? We know that the side is 3.75 feet, and this diagram here tells us that the height of each triangle is 5.77 feet, right? So my decagon has 10 sides, and therefore 10 triangles. Area of triangle equals half times base times height, which is equal to half times 3.75 times my height was 5.77, right? So let's do this. 3.75 times 5.77, that is half times 21.6375, which is equal to 10.81875. And let's see, that just gives me the area of the triangle, right? So now I have area of decagon equals area triangle times 10, which is equal to 10.81875 times 10, which is 108.1875 square feet. Don't forget the units. There you go. Now, that's just the square footage. What is the next thing we know? We need to find out. We need to find out the cost per square. We're given the cost of tiles per square foot. So our next step is to find out cost of tiles, right? Let's do this. I don't have much space. I'm just going to do this on this side. Cost of tiles is going to be 108.1875 times 2.89. Times 2.89. That gives me 312 point, and now I'm going to round it to 2 decimal places because that is in dollars and cents. $312.66. That's going to be my total cost. All right, I want you to pause. Let's talk about this. How can you solve the problem a different way? Can you solve it a different way? I want you to add this to the exit ticket. This will be part of your exit ticket. And let's see. Here's your check problem for today. Pause, solve this on your own, and I'll share the solution. There you go. That's going to be $760.49. All right, I want you to think about this. Compare finding the area of regular polygons with finding the area of irregular polygons. What is an irregular polygon? An irregular polygon would be something which has sides of different sizes and varying angles. Therefore, you cannot just directly divide them and multiply, right? You'd come up with different shapes. So, compare this. What are some similarities? What are some differences? And that's it for today, guys. I'll see you in class next time.